Welcome, and thank you for your interest in our workshop on the challenge and promises of inferring emotion from images and videos. And thank you for your interest in my talk too. And my name is Qianli Feng, and I am the organizer of EmotioNet Challenge 2020, which will be the topic of this talk in the next 15 minutes. So I will provide you a summary of EmotioNet Challenge and the result for EmotioNet Challenge 2017 to 2020. Okay, let's get started. So EmotioNet Challenge is a competition on developing computer vision algorithms for automatic facial expression analysis in the wild. Here there are two keywords, facial expressions and in the wild. By facial expressions, we meant facial action units in a facial action coding system, where the action units are defined as observable muscular movement on faces. In the wild, we meant the images used in our data set are collected from internet. So the images are actually directly used from the EmotioNet database, which is published in CVPR 2016. The in the wild features of the challenge make it particularly challenging due to the large variation in the head pose, illumination, facial occlusion, skin color, and etc. So here we provide you a few examples from the data set. And challenge in 2020 is the third EmotioNet challenge, and with previous two held in 2017 and 2018. So each year we're trying to introduce some new features to the challenge, and this year is no exception. The EmotioNet Challenge 2020 provides 11 more AUs comparing to what we had in EmotioNet Challenge 2018. And that brings us to a total of 23 AUs manually annotated on 91,000 images. Here in the table, I provide you a bit more detail on the breakdown and the exact breakdown of our data set. So we have two subsets as training set. The automatic set, which is annotated by an automatic algorithm, is pretty large. It has about 950,000 images. So another set, also for training, is called manual set, or sometimes the optimization set. This set is smaller. It has 24,000 images, but it is annotated by professional fax coders. The validation set and testing set both does not provide annotations to the participants, are also manually annotated. The validation set has 20,000 images pre-augmentation and 100,000 images after augmentation. The testing set on the other hand, has 50,000 images pre-augmentation and 200,000 images post-augmentation. And here by augmentation, we meant the different scaling and random facial occlusions. So now that we know that some basic information about EmotioNet Challenge and Challenge 2020, I want to introduce a little bit more information on the bias of the data set. The bias of the data set is particularly of interest if we are trying to interpreting the results, right? Or we're trying to apply the algorithm developed by EmotioNet into some other practical setup. Because of the constraint on time, I'll only introduce three biases that exist in our data set. One is on age distribution, the other on gender, and also the AU activations. First, let's discuss the potential bias on the age distribution in the EmotioNet database. The figure on the left is the parent age distribution of samples in the EmotioNet Challenge. The figure on the right shows the age distribution on the US general population provided by Census Bureau in 2019. So as we can see, the EmotioNet Challenge has most of its sample concentrated around 20-year-old to 50-year-old. But on the other hand, the US general population is more evenly distributed from newborn to 65-year-old. So there is quite a bit significant difference from the challenge distribution to the US general population. So next to the gender distribution, similar as the figures in the last slides, on the left we have the gender distribution in the EmotioNet Challenge, and then we have the general distribution US population in 2019. And so as you can see, the female percentage in the EmotioNet challenge is much higher than the female percentage in the US general population. We have about 65% of samples contain female individuals in EmotioNet challenge, where the general population, there's only approximately about 50% of the females. So that's also a very interesting, but very significant difference right there. So now that we talk about the bias in the image or in the demographic of the individuals in the EmotioNet challenge, we also want to talk about the differences in terms of the AU activations. So in this figure, which is the figure on the right, that we are showing the percentage of AU activation. That is across all AUs. So for each AU, the red bar represents the percentage for activation, and gray bar for absent. So as you can see, some of the AUs have very few activations, meaning they rarely present in the data set. So those are AU 9, AU 17, AU 20, and AU 28. But some other AUs have much more presence than the other AUs than in our data set. For example, there are AU 10, AU 12, AU 25. All right? So handling this imbalance is not only challenging for developing an accurate algorithm, but also for developing a criteria, a objective criteria to evaluate the algorithm. So for example, if we just use the accuracy as evaluation criteria, then an algorithm that's always produce negative result across all AUs, across all images, will have a pretty decent accuracy, because as you may notice, most of the AUs have percentage activation below 50%, and most majority of them are below 20%, right? So a all negative algorithm, which doesn't really learn anything but a existed bias of the prior in the data set, will do pretty good. So what is the evaluation metric that we use to rank our participants? We use a score that is the average of the accuracy and F1 score. So here, when we say accuracy, it's the mean accuracy across all AUs. And for F1, we meant mean F1 across all AUs. So accuracy gives us a pretty intuitive understanding of the overall performance, but F1 score is more sensitive to the true positive and as well as the imbalance in terms of the activation of the AUs. So one things I want a bit more attention to is that in the cases where there are actually no true positive in the submitted results, so that means that all the images are estimated as negative for some AU, for a specific AU, which was the case we talked about earlier. In that case, F1 is equal to 0. Is equal to 0. All right. So it is having a 0 for some of the AUs. That is a severe penalty when we average across all AUs. So we discourage the algorithm to produce results that for some AUs that every image is negative. And this is based on the expansion of the precision recall formulation of F1 that is also provided at the bottom of the slide. So in terms of participation status, we have 77 groups registered to participate in the EmotioNet challenge this year. And 7 groups in total of 24 submissions are submitted during the validation period. And in the testing phase, there are 5 groups finally submitted their results. So let us take a look at the result from 2017 to 2020. And this is, on the white axis, is the final score. On the x-axis is the time, and each dot, each yellow dot in the figure is a participant. So this is evaluated on the validation set for 2020 and 2018 challenge, but it's the testing set for 2017 challenge, since they have the image correspondences. And we are now only evaluating on 11 AUs, which is the 2017 AU set, because 2017 participants didn't have result for the 2018 and 2020 AU set. So as you can see, when we evaluate on this subset of AUs on this validation set, we can see that the top performers, their performance improves over time, right, which is shown by a dashed red curve in the image. So from 2017, the final score is around 0.73, but but in 2018, this score goes to 0.78, and this year, two of our top participants provided a score that is that is above 0.8. So there is improvement in terms of the state of the art in each year. So what about the scores? What about the result this year? So when we're evaluating on the challenge set of this year, in the red box, that is, we provide final score on 2020 AU set, that is 23 AUs, and 2018 AU set, that is 12 AUs. And as you may notice, that there is a significant drop for most of the participants in terms of their final score when we're looking at the final score in 2018 to the final score this year. So it implies the difficulties that introduced jointly from our specific set of AUs that added in this year challenge and overall the training setup. So EmotioNet Challenge 2020 is pretty challenging for the following reasons. AU activation, first, is highly imbalanced. And second is the automatic training set is pretty large, but it's pretty noisy in terms of its annotation. On the other hand, the manual annotation, the manual training set is pretty accurate in terms of its labeling, but it's very small. So how do we leverage the pros of this two training set and avoid the cons? Is an interesting question to be addressed in terms to perform well. And then is how do we address the phases of different head poses, backgrounds, illumination, etc. All of those factors has to be taken into consideration to produce a well-performed algorithm. So you might be curious of how did the top 3 participants address these problems? So we are fortunate to invite top three participants this year to give a talk in our workshop. So first we will have Pengcheng Wang from TAL Group in China. He will talk about how he and his colleague use an algorithm with multi-view features to solve the multi-label problem with a consideration on different models conversion rate for different AUs. And then we have Philip Warner from University of Magdeburg, and he will talk about how to use a self-training and a specific multitask learning to leverage the large noisy automatic set but small but accurate manual training set. And last but not least, we have Sijie Ji from the joint team of from CIAT and NTU, will illustrate how to use selective learning and model ensemble to achieve a better performance. Right? And that's all for my talk. And thank you very much for your attention. If you have any questions and comments, please leave a reply below. And I hope you enjoy the rest of your CVPR workshop and the CVPR as well. Thank you.